Hi, today we're going to do some homework examples from lesson 5.1. Just so you know, we're going to do numbers 38, we're going to do number 46, and we're going to do number 58. So if you need to fast forward, go ahead and do so throughout the video. Number 38 says, in the directions, use the definition of inverse functions to show analytically that f and g are inverses. If you're going to show that f and g are inverses, then you're going to show that f circle g of x turns out to be x. And if you're going to show that these are inverses still, you got to do it the other way too, which is g circle f of x, which also equals x. So you've got to show both directions. Well, that means the top definition here we've got to do is f of g of x, which means we're going to put all of g into f. So x minus 3 over 4 is all going to go right here where that x is. So we're going to say 4 parenthesis, and we're going to place all of this in there, which is x minus 3 over 4. I'm going to close up the parenthesis, and then we're going to bring down this plus 3, which was after the x. We're going to go ahead and work this out. Let's see, in this case, I'm going to change colors here so you can see this nice and easily. These 4s, one's up, one's down, which means you're dividing. 4 divided by 4 is 1, so it's just 1 times x minus 3, which is x minus 3. That's all that's left there. But then we still have this big plus 3 on the end. And it looks like minus 3 and plus 3 will go together and make 0, and the answer is x. So we proved this side of the formula. It just had to equal x. Now we're going to go ahead and do the other side, which says that we have to do g of f of x. And this time we're going to take all of f and we're going to put it into g. So 4x plus 3, which is f, is all going to go right here on top of this fraction. So we're going to go ahead and write, instead of saying x minus 3, we're going to put 4x plus 3 right here. So 4x plus 3, that replaced the x. Now we're going to write the minus 3 divided by 4. Let me write that a little prettier this time. All right, minus 3 divided by 4. What can we put together here? We have a 3 minus a 3. So that would leave us with 4x over 4. And it looks like we can divide 4 divided by 4 and make a 1. And the only thing left is x. Since we made x both directions, that means that we have proved that these guys are inverses. So yes, f of x and g of x are inverses. And again, I apologize for my writing, but I am on a little wireless board here. It's not the easiest thing to write on. So, but yes, f and g are inverses. So that concludes number 38. Now we're going to go on to number 46. The directions say, determine whether each function is 1-to-1. If so, find its inverse. So function g is a set of points this time. First of all, if it has an inverse, it has to be 1-to-1. Which means, are all the x coordinates different? 0, 1, 2, 3. Yes, they are. They are all different. Now, that means that what that means is that it's going to pass the vertical line test if I were going to graph this. Now you have to look and see, are all the y coordinates different? 10, 20, 10, and 40. You have these two guys right here that are the same, okay? Since you have two y's that are the same, if you were to graph this, since the y's are the same, you would be going up the same amount, which is 10 on both sides, which means this graph would not pass the horizontal line test. And since this graph does not pass the horizontal line test, it means by definition that it does not have an inverse to itself. So no inverse exists. And because you don't have an inverse, there's nothing to do for the problem. Okay? All you had to do is write that an inverse does not exist. Now, if it did exist, then you would have taken each of these points and you would have reversed them. So this would have been 10, 0. This would have been 20, 1. This would have been 10, 2. And this would have been 40, 3. Because that's what you do to find the inverse. You would switch x and y's. But no inverse can be found. So problem 46 is complete. Now we're going to go to the biggest problem, which is number 58. All right, let's read the directions on number 58. It says, for each function defined that is 1 to 1, write an equation for the inverse function in the form y equals f inverse of x, and then graph f and f inverse on the same axes. Give the domain and range of f and f inverse. If the function is not 1 to 1, say so. All right, so first of all, y equals negative x to the third power minus 2. I'm just going to make a little sketch of this really quick. First of all, I'm going to just make a little quick sketch of the parent. Okay, the parent is a snake function. Comes through about like this. Okay, does the parent pass the vertical line test? And the answer is yes, because these do continue to go out little by little to the right, and this one down here continues to go out little by little to the left. Does the snake graph also pass the horizontal line test? And the answer is yes. It only strikes the graph once every time. So to think of the parent being the snake graph, this graph is going to be a function. It does pass both the vertical and the horizontal line test. So what I'm going to do is I'm going to take my eraser here. I'm going to go back over here to my graph. I'm going to erase this. And we're going to graph y equals negative x to the third power minus 2. Now, just to let you know, if I was to make a quick sketch of this, okay, not even worrying about points at all, not even worried about points, I would have to take the parent and reflect it across the x-axis, and then I would have to move the graph down 2 units. So if I go across the x-axis, this piece down here would end up coming up here, and it would be coming down this direction. Now, since the graph itself is going to move down 2 units, it's going to be moving down to here where it crosses over. So it would be crossing through here, and then it would cross through there, and it would continue this direction. And this is just a sketch of where this graph would be. Now you can tell by looking at it that it does pass the vertical and the horizontal line test. Now I'm going to go ahead and erase this one more time, and we're going to do this even a little better. Okay. Now definitely we know that it crosses right here. The parent got moved down 2 units. I'm going to go ahead and put in negative 1. This would turn out negative 1 to the third power is negative 1. Negative 1 times negative 1 is positive 1. And positive 1 minus 2 is negative 1. So that would put us here. Now you got to think the snake graph goes here, here, and here. So if that graph's there, you're also going to have one right here. Now, for the parent graph, it went up to 2, 8. I bet this one's going to be down, instead of 8, it's going to be down to 6 because you're going 2 less. So let's come back over here and check negative 2 out. Negative 2 to the third power turns out to be, negative 2 to the third power turns out to be negative 8. Negative 8 times negative 1 is positive 8, and 8 minus 2 is 6. So at negative 2 it is 6. Now, normally it goes to 2, negative 8. 2 less than that is going to get us down to negative 10. You can check that for positive 2, but it's going to be down at negative 10. Now, I'm going to go ahead and sketch this graph in. I'm going to change the color here so you can see what's going on. I might have to pause here for a second to finish drawing it because it's the wireless board, and it makes it a little tough to continue drawing it without lifting my pen off the pad. All right. So right there, this guy is the original function, okay, which in the book in the definition it says it's y equals, but it says that y is f inverse. Or I'm sorry, is f of x, okay? So I'm going to go in here and I'm going to go ahead and write f of x. Now our job is to find the inverse. Not only do we have to find the inverse, but we also have to graph the inverse. Well, first of all, let me tell you that graphing the inverse is pretty simple. I'm going to go ahead and change colors here. I'm going to get a nice little purple here. And if you're going to graph f inverse, by definition, all you have to do is switch x and y. So if this point down here is 2, -10, then you're going to do -10, 2. So -10, 2 puts me here. This point is 1, -3, so it would be -3, 1. This point is 0, -2, so it's going to be -2, 0. This point here is -1, -1, which is again going to put you at -1, -1, so it's going to be there again. And this point up here, which is -2, 6, is going to turn into be 6, -2. Okay, so the graph of this, and I'll just give it a nice little black here. This might be a little tough to draw sideways with my little wireless board, but we're going to try to do it. And we're going to make sure we put arrows on both sides. And this one turned out to be f inverse of x. Okay, now just to reiterate, okay, the definition of f inverse. If you really did it right, what we talked about in class is that if you draw, and I'm going to use my little helper up here so I can draw a nice straight line. I'm using this little wireless board here. If you were to draw the line y equals x, which goes from this corner here all the way up to, and I apologize for this, I got a little wireless board that doesn't want to draw everything completely the way I want it to the first time. If I can get down there one more time, from here all the way up to here, as far as we can go. Are those two graphs, the red one and the black one, are they reflections of each other across this graph? You know, this red piece here reflects across and becomes the black piece. And this red piece here reflects across and becomes the black one here. So yes, they are inverses of each other, and they're inverses across the line y equals x. That's by definition. Alright, so we're done with the graph. Let's come over here and let's go ahead and find the inverse. Okay, we're going to look for f inverse of x. That's what we're going to look for. You have to switch x and y, which means instead of y equals, we're going to write x equals. Instead of negative x to the third power, we're going to write negative y to the third power, minus 2. We're going to solve for y, which means we're going to move this minus 2 across with a plus 2. We're going to draw a line. So that would be x plus 2 is equal to negative y to the third power. We're going to divide by negative 1, which is this negative right here in front. And we're going to divide this side by negative 1. Now, just to make this look a little prettier, okay, if you divided these two, this would be a negative x. You have a positive divided by negative, which is a negative. If you divide these two, that makes a negative 2. So you don't have to leave that particular problem as a fraction because it divides nice and easy. And this is y to the third power. Now, if you're going to cancel out a third power, I'm going to go ahead and change colors here because we're going to cancel out a third power by taking the cube root of both sides. You know, like a square cancel out a square root, a cube and a cube root cancel. So I'm going to take the cube root of this side. And I'm going to kind of switch it around. All of this side turns out to be y. That's all that's left. And this is y equals the cube root of negative x minus 2. I'm going to go ahead and rename it because y really in this case is f inverse. That's what we're trying to find to begin with. F inverse of x turns out to be the cube root of negative x minus 2, and that completes problem number 58 because we found the inverse. And I believe that problem is done. So that completes number 58, and that completes our video over these 3 homework problems.